in the previously discussed car class, there are many things that are new to us. Let's take a look at each one and see what it is that they do. I encourage you to have the cars.py file open so that you can see easier some of the examples and what exactly is going on. So Python class. Python is an object-oriented programming language. And as I said, almost everything in Python is an object. An object is an instance of a class. Objects have their sets of properties and methods. Properties in an object are those internal state variables that we saw identified by self. And methods are ways you can access and modify those internal state variables. So an object is as I said, state of a class. Now, a class defines what's called an object constructor. It's a way to construct, to build an object of that class. And think of it as like a blueprint. A class is a blueprint. It has everything you need, like a blueprint, for building objects, for constructing instances of that class. The syntax of the class, as we saw, so it starts with the keyword in Python class, then space, and then the name of your class. By convention, the variables of the names of classes should be capitalized. They don't have to be capitalized, but it's convention and you should always follow conventions. In our definition of the car class, we saw everywhere this weird self variable, right? It was passed into every single method for some reason. So again, the naming convention, it does not have to be called self, but you should call it self because it's convention for a reason, right? What self is, it's a pointer. It's a reference to the current instance of that class. That is the object. And it is used to access variables of that class, right? That is how you access that internal state of an object, is by the self variable. It is, so even though it doesn't have to be called self, although you should call it self, it does have to be the very first variable passed into a class method. And one thing to note, if you look at the code file, the self variable is always omitted. It is not included in the comment section, in the arg section of comments. You never say what self is because it is implicit in how Python interacts with objects of classes. So you never have to say that, yes, self is a variable that is a reference, blah, blah, blah. You always omit that from there. Now, one of the very first things in the class is this __init___ method. It is a reserved method in Python, and you should only ever use it for one very specific purpose. What this is, it's a built-in constructor or initializer method. That's why it's init, short for initializer. What it does, it implicitly instantiates an object. It creates and it builds and initializes it. And you never call it explicitly. You never call this init methods, say, when you want to create an object of a class. Simply by using the proper constructor of a class, that's what calls the init method and actually creates your object for you. It is included in all classes in Python. It is required. It is how Python creates an object, an instance of that class. It is always required. And so, yeah, it gets called implicitly when you create a new object, and it itself doesn't really return anything explicitly, although implicitly it returns this self reference to the object, and that's how the object of a class gets created. And what it does, it very often initializes some internal state variables or fields or properties of an object. So those properties are not accessible outside of that class, that they are contained within the object, and in order to access or modify them, you have to call methods, as we'll see shortly. But yeah, so like this is our example from the cars.py, and what it does, we completely ignore this self parameter, but you see what this does. We have our make, model, year, color, and odometer parameters. And how you often initialize an object, you say self dot whatever you want to call internal variable gets whatever was passed in the constructor. Now, I only named them here the same, and most of the time you do, but you don't have to. You could say something like self.manufacturer gets make, right? Just a different word for the brand of the car. But yeah, they don't have to be the same. What you see on the right side of the assignment, they do have to match whatever you passed into the initialization method, but on the left you can call them whatever. But mind you, then in the rest of your class, in every method, you'll have to remember what you called them, so don't call them against something that is not intuitive. These are in fact variables, and as all other variables, they need to be very descriptive and properly formatted. And again, the naming convention goes as for all other variables. You say it cannot start with a number, you should know it by now. This other weird method, the stir method. Every object it doesn't have to, but it should have a proper string representation. And remember this casting function str when we called it on ints or floats to convert them to a string? So for custom objects, whenever you invoke this function, so str of object, this __stir method gets called implicitly, and that's what you can actually provide your object with a custom print statement, right? Just like we did here. So what this method does, it overrides the default class definition of the stir function, whenever you want to call it, right? Now, if you tried to print to do stir of an object without first defining the stir method, you would have something very different, and it wouldn't be quite useful, right? Calling stir of object or simply print object, it implicitly calls this predefined method that has very specific meaning in Python. And for example, this is the same as in our cars.py file. So we return this custom string, we concatenate the year, space, color, space, make, space, model of the vehicle. And you can see after the init and store method of the class, there are other class methods. So each class can have 0 or more special methods that are used for accessing and modifying the internal state of the object. So the init and stir methods, they are built in, and you cannot use them for anything other than what they are intended for, because otherwise you'll probably get errors or the program simply would not behave correctly. Now, the custom methods of a class, they are classified in two different types. They're called getters and setters, and they usually either get or set object properties. So getters are overall, it's a type of functions that retrieve information of the internal state of the object. It retrieves those self variables, self.make, self.year, self.whatever. It should not be used to set them as well. Now, setters are a type of method that update the internal state of the object. And again, this internal state or internal variables or fields, they're also called properties. These are all used kind of interchangeably. Now, one very important point. The internal state of an object must not be modified or retrieved or modified outside of the class definitions. So for example, you should never in your code issue statements like car1.odometer gets something else. The internal state of the object must only be accessed or updated using the methods of that object. Even though some programming languages allow you to interact with objects immediately, you should never ever do this, and it's a very poor programming style, even if you're allowed to do so. So only ever use methods for both accessing and updating internal variables of your objects, such as for our cars, for example, make, model, year, color, and whatnot. And as we saw before, the syntax for that is the name of the object, for example, car_1, then dot, and the name of the method, and of course some parameters. Note again that you never pass the self parameter. The self parameter is this object name dot. You are referencing a particular object, so car1, car2, or car3. That is why the self gets passed implicitly in the parameters, but explicitly when you call the object by its reference, by its name, the name of the variable. And so these, the init method and the stir method. So init is completely implicit, you never call it in the first place. However, the stir does not behave like other class methods. As you can see here, it is called like other functions we used before. Right, you say the function name, and then you simply put the object as whatever you are targeting with this function. Not so for all of the other class functions. So the syntax is very important, as you will see later on. It is the name of your variable dot the name of the method you are invoking, and then if it does take any parameters, you pass them. For example, the travel method takes distance as parameters, but a getter like getOdometer had in fact no parameters and simply returned the odometer reading of a particular vehicle.